Hello everyone, welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry at this platform. I hope you all are good, you all are doing well. Your studies are going in a smooth manner and you are very consistent with your studies because you know consistency is the key to clear any exam in life, to get success in your life. So guys, this is our GATE exam syllabus, which is chemistry for Excel candidates, and this is our section 1 which we have studied in the previous lectures named atomic structure and periodicity. Now we are going to study about structure and bonding, which is our section 2. These are the topics which you can see on the screen. We have covered these topics in the previous lectures. And now we are going to study about chemical bond, which is our section 2, which is very important for the exam. So basically, a chemical bond is a lasting attraction between atoms, ions or molecules that enables the formation of chemical compound. Or a chemical bond is a force that acts between two or more atoms to hold them together as a stable molecule. This chemical bond may result from the electrostatic force of attraction between oppositely charged ions, as in ionic bond or covalent bond, through the sharing of electrons. This chemical bond is the union of two or more atoms involving and distribution or sharing of electrons among them. For example, in case of HCl molecule is formed from two different atoms, that is H and Cl. H atom and Cl atom combines to form a HCl molecule, where H has 1 electron in its outermost shell, while chlorine has 7 electrons in its outermost shell. Chlorine needs 1 electron to fulfill its outermost shell. Therefore, it makes a chemical bond with hydrogen, where hydrogen shares a single electron to chlorine. That's why chlorine can attain a noble gas configuration. Chlorine can attain a stable configuration. So basically, chemical bonds are formed between atoms to get a stable configuration. The third point is decreases energy is proportional to the strength of bond. Therefore, molecules are stable than atoms because molecules has least energy as compared to atoms. Now, the classification of bond. Basically, chemical bonds are majorly of two types. Number 1 is strong bond, which has the energy of 200 kilojoules per mole, while metallic bond, which is intermolecular, and it has the energy of 2 to 3 kilojoule per mole. You have to remember the energy of strong bond and energy of weak bond. Strong bond consists of the 4 major type of bonds named ionic bond, covalent bond, coordinate bond and metallic bond. While weak bonds has 2 types of bonds named hydrogen bond and van der Waals bond, which has the energy of 2 to 3 kilojoule per mole. Next is the cause of chemical combination. We have seen what is chemical bond, but why this chemical bond is forming between the atoms. So the number 1 cause is tendency to acquire minimum energy. As you know, if the molecule has least energy, only then the stability of that particular molecule will increases. So basically, when two atoms approaches to each other, nucleus of one atom attracts the electron of another atom. When two atoms are combined, nucleus of one atom attracts the electron of another atom. If this net result is attraction, then the total energy of that particular molecule will decreases. In case of if attraction increases between two different atoms to form a molecule, its energy decreases, and if the energy decreases, the stability increases. So this point is very important. As the attraction increases, energy decreases and stability increases. Second point is tendency to acquire noble gas configuration. So basically, as you know, if the molecule has noble gas configuration, only then the energy of that particular element, energy of that particular molecule will increases. Energy means stability increases. Atom combines to acquire noble gas configuration. Only outermost electron participates in the bond formation. Also, inert gas elements do not participate as they have stable electronic configuration, hence they had minimum energy and are most stable, because as you have seen here, if the energy decreases, the stability increases. Now we are going to study about the strong bond, that is your covalent bond. So basically a covalent bond is also called a molecular bond because it is being formed between two atoms and these atoms combines to form a molecule. It is a chemical bond that involves the sharing of electron pairs between atoms. The shared pair of electrons are known as shared pairs or bonding pairs, and the stable balance of attractive and repulsive force between atoms, where shared electrons is known as covalent bonding. Or you can say a covalent bond is formed by the mutual sharing of electrons between two atoms of electronegative elements to complete their octet. So basically, for the formation of covalent bond, the two atoms must have the difference in their electronegativities. The shared pair of electrons should have opposite spin. As you have seen in the previous video of structure of atom, the electron should have the shared pair of electrons should have opposite spin. Covalent bond has the directional character. For many molecules, the sharing of electron allows each atom to attain an equivalent of a full outer shell corresponding to a stable electronic configuration. Now, this sharing of electron in case of covalent bonding may occur in three ways. Number one is number of electrons shared between two atoms, which means if the number of electrons shared between two atoms is 2, then the electron pair will be 1 and the bond formation is known as single bond. As you can see here, carbon and carbon, between carbon and carbon a single bond is formed, and this bond, and we can show the bond formation by a single line. Once again, this is the annotation to show a formation of bond. Single bond, this is single bond and it has two electrons, 1 and 2, and two electrons combine to form a single pair of electrons. So as you can see, number of electrons shared between two atoms is 2, that's why electron pair is 1, and this one electron pair means single line, single bond, and this is known as single bond. Second is number of electrons shared between two atoms is 4, then the electron pair will be 2. As you can see, this is your double bond. The electron present is, number of electron present are 4, 1, 2, 3 and 4. If number of electron between two atoms is 6, then the electron pair will be 3, and this is known as triple bond. Now the orbital concept of covalent bond. So basically these are some rules for the formation of covalent bonding or for the orbital concept of covalent bond. One orbital can accommodate at most 2 electrons with opposite spin. This point have been cleared in the structure of atom lecture. Half-filled orbitals or unpaired electron orbitals accept one electron from the another atom to complete its orbital. Tendency to complete orbital or to pair the electron is essential condition for the covalent bonding. Covalent bond is formed to complete the orbital to attain the stable noble gas configuration. That's why this is the foremost essential condition for the formation of covalent bonding, that is tendency to complete orbital or to pair the electron in is the essential condition. Next point is very important. This is your covalency. It is defined as the number of electron contributed by an atom of the element for sharing with other element to achieve noble gas configuration. If the outermost orbit has empty orbitals, then covalent bonds are formed in excited state. Next is variable valency in covalent bonding. Variable valencies are always shows by those elements which has empty orbitals in their outermost shell. Now valencies are the unpaired number of unpaired electron present in a particular atom, and covalency are the valency in which the electron of one orbital can jump from one orbital to the another orbital. Means an atom can increase its valency, and that increment in the valency is known as covalency. An atom can have multiple covalencies depend upon the number of electrons present in the orbitals. So basically the energy required for excitation of electrons is called promotion energy. And if the energy is being promoted, if the electron is being excited from one orbital to another orbital, there comes a promotion rule which states that excitation of electron should occur in the same orbital. For example, as you can see here on the screen, number one example is for phosphorus. First of all, you need to write the electronic configuration of phosphorus. Now, you have to make the different orbitals of phosphorus, and when you fulfill the electrons in the phosphorus, you will see that 3s orbital has paired electrons while 3p has unpaired electrons. And as you know, valency is the number of unpaired electrons present in the outermost orbital. So basically, as you can see here, 3p has 3 unpaired electrons. That's why the valency of phosphorus is 3. And when the valency of phosphorus is 3, it makes a molecule with chlorine atom of 3 chlorine atom and makes a formation of PCl3. While if you see here the excited state of phosphorus, this paired electron present in the 3s orbitals jumps into the 3d orbital where all the electrons are unpaired. So basically, when all the electrons are unpaired, the covalency increases from 3 to 5, as you can see here. So basically, when the covalency is 5, phosphorus atom combines with 5 chlorine atoms to form a molecule that is known as PCl5. So from here you can conclude that phosphorus has variable valency, that is 3 in its ground state, and in its excited state it is 5. In another example of sulfur, in its ground state, as you can see, it has 2 unpaired electron in 3p orbital. That's why it has the valency of 2 and makes a formation of SF2. While in its excited state, in its first excited state, only one electron jumps from 3p orbital to 3d orbital. And when one electron jumps from 3p orbital to 3d orbital, the covalency becomes 4. As you can see, number of unpaired electrons are 4. That's why it makes a stable molecule, that is SF4. While in its second excited state, this one paired electron jumps here, and this makes the formation of covalency of 6. Here also a single electron is also present in 3d orbital and makes the formation of SF6, as also in case of iodine 2. Next is application of variable valency. We have seen the valency, we have seen the covalency. Valencies are the number of unpaired electrons present in an atom or molecule, and covalency is the excited state of the excited unpaired number of electrons present in the particular atom or molecule. So now the application of variable valency. Number 1 is to explain the existence of molecule. Only those molecules will exist which has the variable valencies, and these variable valencies should have the empty orbitals too. That's why if the valency has unpaired electron, only then, and if it has empty orbital, only then these paired electron can jump from ground state to excited state. And when these electrons jump from one orbital to second another orbital, only then the formation of covalency will occur. So basically NCl3 will exist because nitrogen has the unpaired electrons 3. That's why these 3 unpaired electrons makes the bond with 3 atoms of chlorine, and that's why NCl3 exists, while NCl5 do not exist because nitrogen do not have the empty d orbital, or we can say nitrogen do not have the d orbital in its outermost shell. That's why the unpaired electron cannot jump from its one orbital to another orbital. Next, in case of PCl3 and PCl5, these both molecules will exist due to the presence of 3d orbital. Next is OF2 will exist, but OF4 and OF6 will not exist due to the absence of d orbital. This slide is very important because many times questions have been asked in the exam which molecule will exist or which molecule will not exist. These are the famous examples of the existence of molecule application of variable valency. So I would suggest please note down these examples and learn them quickly. Second is hydrolysis of compound. These two reactions are also very important because they have been asked a number of times in various competitive exams. CCl4 plus H2O, when you add CCl4 with water, no reaction will occur because due to the absence of d orbitals. But in case of SiCl4 plus H2O, reaction will occur due to the presence of empty orbitals. Next is characteristics of covalent bond. So basically number 1 characteristic is its physical state. Covalent bonds are found in the 3 states, that is gas, solid and liquid. As the molecular weight increases, physical states changes. Physical states changes from top to bottom because van der Waals force of attraction increases between the molecule. Now if we talk about in case of halogen from top to bottom in a particular group number 17, fluorine and chlorine has gaseous states while bromine has liquid state, and iodine and antimony has solid state. Next is covalent solid. Covalent solids are those solids in which atoms are linked together by covalent bond. Atoms are linked together by a sharing of electrons. And these covalent solids makes a infinite 3D giant structures, for example diamond and graphite. You have to learn the example of covalent solid, and covalent solid examples are diamond and graphite. Third point is conductivity. Most covalent compounds are the best conductor of electricity due to self-ionization. Free ions are formed which can conduct electricity, and exceptions are graphite and HCl in water. Fourth point is solubility. Non-polar compounds are soluble in non-polar solvents. For example, non-polar compounds example is benzene. Isomerism. Covalent bond is rigid and directional, so it shows isomerism. And isomers has a definition which means these have the same chemical formula, but the structure of a similar formula has different structure. For example, in case of organic compounds such as benzene C6H6 shows isomerism. Next is reaction. Reaction between covalent compounds are comparatively slow because for the formation of covalent bonds there is a requirement to break the old bonds and new bonds formation take place. Now till now we have completed in this particular lecture about chemical bond and covalent bonding. I hope now you all are cleared about chemical bond, why the chemical bond is being formed, what is the basic reason to the formation of chemical bond, what is covalent bonding, and what are the different properties of covalent bonds. Now in case if you are new here at this platform named Gurmantra Shiksha Ka Granth, please do like, share and subscribe to our channel. You can also join our Telegram channel named Gurmantra. At our Telegram channel you will get the new updates related to your exam. You will get free PDFs, notes here. For further queries, you can also mail us on the given email address, and you can also contact us on the given number. Thank you very much guys. I hope now you all are cleared about the chemical bond.